Okay, in this video, we'll do the week 6 probability homework together. First and foremost, there is probability learning materials located at the bottom of the home page as usual, and you can also navigate to this from the modules section, which is probably where you're going to get to it. So definitely check out the text and this video on base rate neglect and Bayes' theorem. Let's navigate to the modules section and then to week 6. So here's that same page I was just at. Click on the homework. Okay, so there are many boxes in this particular homework, you've probably seen this before, that are not questions. Canvas has a limit on how long a question can be, so it's broken up into a bunch of these boxes, which sort of guides you through things. Our goal in this unit module and in this particular homework is to focus on the conjunction fallacy and the base rate fallacy, and we will be illustrating why exactly these are fallacies by doing the math and trying to visualize it. So we'll start with the conjunction fallacy. Our first introduction to the conjunction fallacy was near the beginning of the course when we did biases and the representativeness heuristic. If you remember the Linda case where you were told that Linda, basically she was described and she sounded a lot like a feminist, and many people reason that it is more likely she's both a banker and a feminist than just a banker. But the conjunction of two things is not more probable than just one of those two things happening. So one thing that could be going on is that people are focusing in on fit with a stereotype. She sounds like a typical feminist, so she probably is one, and ignoring this more general information, this background information, that a conjunction of two things just isn't more probable than one of those things. In order for her to be a banker feminist, she has to be a banker already. So it's just adding an extra thing that this one person has to meet. So here's a different example. Steve judges that it's more likely for men over 65 to have a heart attack than for men over 18 to have a heart attack. What might be going on here? So this is a toy example. But what might be going on if somebody were to reason like this, that our stereotype of heart disease and heart attacks fits older men, and we sort of hone in on that fit with a stereotype and ignore the fact that men over 18 includes the men over 65. So it wouldn't be more likely to both be over 65 and to have a heart attack than to just have a heart attack. So let our population be adult men over 18, and in this case the outcomes we're interested in, or events, whatever probability we're interested in will get called an outcome or event, is being over 65 and having a heart attack. And Steve is judging that it's more likely that a person is in both of these groups than just in this group, and we're going to show that a conjunction can't be more likely than either conjunct on its own by illustrating it with an example. In particular, we'll visualize it. So I've started here with the rules for how you figure out the probability of two things together, but let's not focus on this now because I think these two equations will be more intuitive when we're looking at a concrete case. There's no point where you're going to have to figure out which equation applies or do math completely on your own in this homework. So the homework starts by doing one together and then asks you to do one quasi on your own, but again, you won't have to do any math on your own unguided. So what we're going to visualize is these two probabilities: the probability of having a heart attack, of any man of any age, adult assuming, having a heart attack, versus a person over 65 having a heart attack, so somebody who meets both criteria. Now, these are not real numbers. These are numbers that I made up that seem in the ballpark of reality and are easy to do math with. So let's assume we're only talking about men over 18, and let's say that of that population, 80% of them are under 65, so between the ages of 18 and 64, and that only 25% of the population is 65 or older. So this is 100 dots. Let this be 100 men. This is the number that would be 65 plus. The writing in purple here is something to pay special attention to as you go through the homework. It clarifies what exactly is happening in this diagram. Okay, we need some more information, and again, I'm just making up these numbers for the sake of doing the math. So let's say that the probability that a man not in the 65 plus age range has a heart attack is 5%. And let's say, again, making it up, the probability that a man 65 or older has a heart attack is 20%. Here's how we'll write the probability information. Probability of H, probability of a heart attack, given that you are under 65. This little bar means given that, and we're saying that's 0.05 or 5%. And let's let the probability of having a heart attack given that you're over 65, so bar over 65. We're saying that that's 0.2 or 20%. So let's represent that information with red dots. We've got 80 black dots, and we're saying 5% of those men will have a heart attack. That's 4 out of 80 is 5%, so let's just pick 4 and make those red. And then we're saying that 20% of men over 65 will have a heart attack. So the probability of a heart attack given you're in this group is 20%. So 20% of 20 is 4. So 4 red dots here. And again, the purple describes what is being represented in the chart. So question, what is the probability that a man of any age has a heart attack? Again, follow this purple writing especially. Just count the number of red dots. 1, 2, 3, 4, 5, 6, 7, 8. So there is an 8 out of 100 or 8% chance of having a heart attack. What is the probability that a person is both in the 65 plus group and has a heart attack? What's the probability of that? Well, now we just count the number of red dots here. 1, 2, 3, 4. So 4 out of 100 will meet that criteria. So now we're going to do the math without this picture, and this is where up front I said how to do the math will be clearer with a concrete example. We'll be using this general conjunction rule. What is the probability that a man both has a heart attack and is over 65? Will be the probability that a man is over 65 times multiplied by the probability of having a heart attack given being over 65. And so why, just to quick clarify, why this wouldn't be this restricted rule. So when two events are completely independent of one another, we just multiply. So an example of two independent events is 2 coin flips. When you flip a coin and get heads or tails, your next flip is not influenced by your previous flip usually. Right? So just standard 2 flips of the coin. So if you want to know what is the probability of flipping 2 heads, well, the first flipping a head's 0.5, the second flipping a head's 0.5, so 0.5 times 0.5 is 0.25. Those are independent events, so you just multiply them. Whereas we are asking what's the probability that a person is over 65 and has a heart attack. And the probability of having a heart attack is influenced by your age, right? So the probability of being over 65 and then the probability of having a heart attack given you're in that group is different from the probability of having a heart attack given you're in the 18 to 64-year-old group. So those are not independent events. The probability of a heart attack is related to your age in some non-independent way. So that's why we're using this equation. So when we do the math, here are our probability calculations. What is the probability that somebody is not in the 65 group, so the other one, the big one, We said that will be 80%. And has a heart attack. To calculate this, we go, what's the probability that they're in that first group? 80. And what's the probability of having a heart attack given you're in that particular group? We said 0.05. And so we multiply those two numbers to get 4%. What's the probability of being 65 plus and having a heart attack? Well, first, what's the probability you're in that first group? 20%. And what's the probability of having a heart attack given you're in that group? 20%. Multiply those, 4%. Finally, what is the probability of having a heart attack for a man of any age? Well, that's just add up these two things. So what's the probability you're either in the first group, the non-65 heart attack group, or in the 65 plus heart attack group? And when we want to know the probability of a disjunction, one or another thing happening, we add them. So this would be 8%. Now that we did one together, the next one asks you to reason through it on your own. So reason through the boxes, even the ones that don't have questions, and pay special attention to the writing in purple. And when you are finally asked a question, sorry, I already had these answered, but when you are finally asked a question, again, watch out for that purple text because it will tell you how to answer it. So what's the probability a man of any age has a heart attack? This is just like the last time, where we just count the total number of red dots. And so you'll answer it, there's 18 red dots, which means 18%. And again, just count the red dots in the blue section. Now it'll ask you to do the math. So we want to figure out what is the probability that you are in the 18 to 64-year-old group and have a heart attack. So you multiply, what's the probability you're in that group? And we have new numbers now. I made them up. So we said this time that 90% of the population is in the 18 to 64 and only 10% of our population is 65 plus. So now this is 90. And we're also, what new numbers did we make up? We've made the probability that a person in this younger group has a heart attack is only 10%, whereas in the 65 group, we ramped it up to 90%. So 9 out of 10 seniors are having heart attacks in this new math. That's not accurate. Okay, so now we have to pay attention to the stuff we filled in. So what's the probability you're in the younger group? Well, that was 90%. And what's the probability of having a heart attack given you're in that group? That was 10%. So again, this just follows the math above, and you should try to follow that and do it on your own. There's a drop-down box, and there's only 3 options to choose from. So try to make sense of what these things are. And again, this one will be these two added together. Okay, so the homework does involve sort of reading through the material carefully, but you won't ever have to do any figure out what it is you're supposed to be adding, multiplying, or whatever completely on your own, and you won't have to supply the numbers. They'll be drop-down numbers. And the second one mirrors the first example pretty closely. So I'm going to end this video on the conjunction fallacy and start a new one for the remainder of this homework on the base rate fallacy.